So this video is for integrated to MA. It is on the honors D-Day #1 for chapter 4. So in the situation on 1A, we have a set of triangles that we're trying to decide if they're similar. And if they are similar, we're going to prove it using a flowchart proof. And if they are not, and if they are similar, we're going to also try to find this side X. So the first thing I notice is this angle G here. This angle G is in triangle GIA and it's in triangle GNT. So that is going to be the first thing that I'm going to talk about. And I'm going to say angle G is congruent to angle G because of the reflexive property. The next thing I notice is this line here and this line here have that arrow here, which means that they're parallel. So if they're parallel, then this angle right here and this angle right here are congruent because of corresponding angles, or this angle here and this angle here. So I think I'm just going to use, well, first let me just say about these lines. So I'm going to say line segment IA is parallel with line segment NT. And the reason is given. Now, that being said, that is going to lead to, and again, I could have used either angle, but I'm going to use those angles there. And I cannot call I, because I could mean here. We aren't really clear as to where angle I is. So I'm going to call this GIA. That's what this angle is going to be called. So angle GIA is congruent to angle N. And I can call N. There's no confusion there. And I'm going to say parallel lines lead to corresponding angles congruent. Now, knowing both of these facts, I now have angle. Okay. So I can now say that because of this and this triangle, let's say I call it GIA, is similar to triangle, and order matters. So if I say GIA, I have to say GNT. And the reason is angle similarity. So now that I know that these are similar, I can now find this side X. Now, in this situation, I cannot use the side splitter because I do not know the other sides here that would have been split. If I did, I could say 6 is to X as this piece is to this piece, but I don't know those. I know this whole side 8 and I know this whole side 12. So I'm going to have to do the following. I am going to stay within this triangle and say, okay, that is 6 is to, and 6 is to this whole side here. And that whole side there is going to be 6 plus X equals, and then I can say 8 over 12 and cross multiply and solve. So I am going to take 12 times 6 and get 72. And I'm going to take 8 times 6 plus X. The 8 multiplies both of them. So I'm going to get 48 plus 8X. And then I'm going to solve. So I'm going to get 8X is equal to 24. So X is equal to 3. On number 2, Mr. Fier wants to build a ramp so he can avoid the steps and roller skate from his sidewalk to his front door. He wants the ramp to slope upward at an angle of 12 degrees with the horizontal. How high does it rise over a horizontal distance of 9 feet? Draw a diagram and use trig ratio to solve the problem. So I'm going to have an angle. I'm going to have a triangle here, basically. This is going to be 12 degrees. And how high does it rise over a horizontal distance of 9? So they really want this. I'll just call it Y. We want that height. So for this, what we're thinking of is SOHCAHTOA. And we need to decide what we have here. So from the 12 degrees, the Y is opposite, the 9 is adjacent. This side over here that I don't know would have been my hypotenuse. So since I know my opposite and adjacent, I am going to use tangent. So I am going to do tangent of 12 degrees is equal to Y over 9. I'm going to multiply both sides by 9. Those are going to cancel out. And so I'm going to do 9 tangent of 12 degrees is equal to Y. And I want to make sure that my calculator is in degrees. And when I put this into my calculator, I do get a 1.913. So let's just say a 9.1. And this is feet. And that is our answer. On number 3, they want us to draw an equilateral triangle. So I'm just going to grab the shape thing since it'll draw it for me. Okay, we'll draw an equilateral triangle. And for this, so let me see if I can actually draw one. Pretty close. Okay. And I'm going to actually copy and paste this. Okay, so in this situation, the sides are 12. Okay, so this is a 12, this is a 12, this is a 12. And because it's equilateral, that would be 60 degrees, that would be 60 degrees, that would be 60 degrees. Now, if I took this, okay, and I split this in half, that 60 would become a 30. This would be a 90 here. This would be a 60. This was a 12. All the way across this was a 12, which makes this a 6. Now we learned, now you can do a Pythagorean, do a right triangle to find this value here. I'm just going to call it Y. Or you can remember a 30, 60, 90. Okay. And so in a 30, 60, 90, across from your 30, if you take that side, which happens to be 6, and double it, you get your hypotenuse. Because again, it would have been half of this side of the equilateral triangle, where this would have been a 12 also. Then you take this 6, you multiply it by √3, and this would be 6 √3. Okay, again, trying to remember the relationship of a 30, 60, 90 triangle. If this is X, this is, whoops, double that, which would be 2X. And if this is X, this would be X times √3. So again, that answer is 6 √3 inches. Okay, on number 4, we have a table here, candies eaten during 1 week, group X, group Y. The data in the table were produced by Ms. Rani, studying the number of candies people ate for 1 week. Group X consisted of 100 sophomores. Group Y consisted of 100 juniors. If a person is chosen at random from those who ate at least one candy, was the probability that that person belonged to group X? So if I am looking at people who ate at least one candy, okay, so at least one candy would be all all of these people here. Okay. Now, the total for that would be 30 and 135, which is going to give me 165 as my sample space, as my new sample space, okay, my new total. Then I want to know what is the probability that they're from group X. So having them be from group X, okay, group X, that would be these 18 and 67. And if I add that up, I'm going to get 85 over 165 as my answer. I could reduce that. It ends up being 17 over 33. And that's my answer. So in this case, it's not out of the total 200. We have a condition, this if, that limits our sample space to only people who have at least one candy, which is everything I have here in pink, which was 30 and 135, which gave me my 165. Out of those, how many were from group X? That's the blue circle I did. 18 and 67, which gave me 85. If the probability of winning $4 on a spinner is equal to the chance of winning $6, okay, so these ones we know are the same. We know that this is basically 90 out of 360 or 1/4, okay? So the others together are going to be 270 out of 360. And if I split that in half, that is going to give me 135 out of 360. So this would be 135 out of 360. And that actually reduces down to 3/8. I'm just going to show another way to have thought about that. So if I know that this section here is 1/4, then that means that I basically had 3/4 left to split in half. And if I take half of 3/4, I get 3/8. So I could have thought of it either way. Okay. Now, to figure out expected value, you take the probability of that amount and times it by the amount you're going to win. So I am going to take 1/4 times a -$7 plus, I'm just going to keep it in the reduced form, 3/8 times $4 plus 3/8 times $6. And I'm going to put that in my calculator. And when I put that in my calculator, I end up getting as an answer $2. Okay, so that's my expected value. Okay, that's what I'm expected to win on average, kind of per game. Calculate the expected value, okay, for one spin, that would be $2. Is the game fair? So the game is going to be fair if your expected value is 0, or if it costs you, let's say, $2 to play and you win $2 and you break even, that would be a fair game. In this case, it didn't say that we paid any money. So since we are getting $2, even though we might in our own heads think it's fair to us, it's not a fair game because expected value is not 0. Since expected value is not 0. Okay. So again, in order for it to be a fair game, our expected value has to be 0, or how much you paid to play is how much you should win back to break even. Okay, let's see. Factoring, 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 factoring. So you want to try to notice things like maybe a perfect square trinomial where you have a square in the front and a square in the back. So remember the formula for this is a squared plus 2ab plus b squared is equal to the quantity a plus b squared. So if I take the square root of this, I get a 5x plus, because the plus right here in front of my 20xy. If I take the square root of this, I get a 4y. Sorry, it's a 2y. I apologize. And then what we need to check is to make sure that we get this 2ab. So in our case, our 2ab is a 20xy. So we check by multiplying these together, which would be a 10xy. Doubling it, I do get my 20xy. So this is my answer. This was a perfect square trinomial. We want to be able to start recognizing those. Okay, on letter B, this one here, I noticed that we have an x cubed, an x squared, and an x. So I can factor an x from everything, and I'm going to be left with an x squared plus 8x plus 12. Now, when we factor, we always factor completely. So can I factor this further? And yes, we can. Think of this as a diamond. I'll do it down here. What multiplies to 12 and adds to 8? Well, a 6 and a 2. So don't forget your x that was in front. And then we have our x plus 6, our x plus 2, and that is our answer. On C, when I see something like this, I'm thinking maybe, well, I'm thinking difference of two squares. So a squared minus b squared is equal to a plus b times a minus b. So when I'm looking at this, the square root of this 16w squared is 4w plus, and I'm going to have that in front of both sets of parentheses. And then my 49k squared will be a 7k when I square root that. One will be a plus, one will be a minus. So when we have two squares separated by a minus, we call it difference, because difference means subtracting two squares. And that's what literally we are doing. We are subtracting two squares. We have a square minus a square. And every single time you're going to have that middle term cancel out because of the plus and the minus in front of your 7k. On letter D, looking at this, I can't factor anything from my variables, a 2, a 5, a 12. I can't factor anything. So this one, I am going to do a box to diamond. So I am going to have my 2x squared here and my negative 12. Those multiply and give me a negative 24x squared. And it needs to add to my negative 5x. So this is where you have to be careful with your signs. It is going to be a positive and a negative that are multiplying. So really, I want a difference of 5. But since my sum is negative, my bigger number is going to be negative. So it's going to be a negative 8x and a positive 3x. So negative 8x, positive 3x. It doesn't matter which box I put which. But now that I've done that, my outside is going to be determined by the setup. So when I'm looking at this, my 2x squared is what I focus on first. And it's going to be a 2x and an x. Putting a 2x here will not help when I multiply to try to get a 3. So my 2x is going to go here to help get my negative 8. So this is going to be a 2x. This is going to be an x. X times 3 will get us this 3x. And 2x times a negative 4 will get us the negative 8x. And so my factors are going to be 2x plus 3 times x minus 4. And we like to write the x's in front instead of writing it as like a negative 4 plus x, for example. It just looks a little cleaner this way. Let's see. Next problem. Okay, so for this, we're just going to substitute these in and we're going to get our answers. Now, what you have to be careful about is that when you put this into like a calculator, you want to put parentheses around your -2 when you square it. Okay, so let me do that for us. So what I mean by this is when, let me just get this a little bigger here. Just maybe as big as I can get it. When we are putting this into our calculator, and I'm putting in a -2, just a quick note, okay? The negative is down at the bottom of these calculators, okay? The minus is here. If I'm going to be trying to start with a number, I can't use the minus because it's really going to be subtracting from the last thing I typed in. So I need to use the negative. Now, if I do -2 and I square it, this calculator is going to give me a -4 because it's doing order of operation. Okay, so what I mean by that, it's going to take that -2 and it's not going to square -2. It's thinking of it as a -2 squared. It's going to square the 2, get a 4, and then make it opposite. So if I want a -2 to be squared, I need to put it in parentheses because anytime I square a number, I should always get a positive out. And I get a 4. So you want to be careful when you enter these in. So I'll enter in the first one and then I'll fill this out. So I'm going to be doing -2 squared minus 4 times, and I'm going to put parentheses for each of them. That way it makes it easier for me to redo this. Minus 5. And it'll give me a 7. So this right here is going to be a 7. And then on these calculators, I can either arrow up and highlight it and hit enter, and then come and just change these numbers to a -1 and a 1, -1, and have it give me the answer. I can also hit second, the blue second button, and this enter button, okay? And the word entry is there. So if I do that real quick, let me just get this clear back off. If I do that real quick, I'm hitting the blue second button and the enter button, it'll retype it. That's also something else I can do. Now, in this case, I'm going to do 0 and then delete because I don't need that other number there. Okay, 0 and then delete. Down the road, I'll show us a different way to do this, but this is how I'm going to show us right now. Okay, and then we can fill out the rest of it. So I'm going to fill out the rest of this real quick. So I have a -2, 7, a -1, 0, a 0, -5, a 1, -8, a 2, -9, a 3, -8, a 4, -5, a 5, 0, and a 6, 7. Okay. And what you'll notice is that it is symmetric. Here, this 2, -9 is actually going to be my vertex. These pair up, these pair up, the zeros pair up, and the sevens pair up. This should be a U-shaped graph. We call this a parabola. So let me graph those real quick. Okay, so I have -2, 7. Oops, that's a little too fat. Let me get a little thinner. So -2, 7. I have -1, 0. I have 0, -5. I have 1, -8. I have 2, -9. 3, -8. 4, -5. 5, 0. 6, 7. And then I'm going to connect these. And that is my graph. Again, it's a U shape. I'm going to actually try to make this a little fainter. Okay. And there's my parabola. Now, in this case, I actually see my x-intercepts. Okay, I have an x-intercept here at -1, 0 and 5, 0. Okay. So again, you see it here and here. So -1, 0 and 5, 0. If it doesn't go exactly on there, you can always put 0 in for y, because you'll notice both of these have a y of 0 and so. And I have a y-intercept, okay, here, maybe I'll do it in orange, of 0, -5. So that's my y-intercept. 0, -5 is my y-intercept. And then a line of symmetry, that's a line that splits this in half. Okay, that makes it a mirror image that's symmetric about. So that is going to be right here at x equal 2. Okay, I'm just going to move it slightly over. Okay, right there at x equal 2. Okay, so that would be my line of symmetry. And so that again is at x equal 2. Notice it goes through this thing here that we call our vertex. So this is going to be x equal 2. Okay. And it is a line, so you need to give me an equation. Okay, on number 8, okay, we're going to solve for these. So looking at this, I have parallel lines, okay, cut by a transversal. So that means I have alternate interior, well, actually in this case, alternate exterior angles that are equal. So I can take 3x minus 8, set it equal to 2x plus 15 and solve. So I'm going to get x is equal to 23. So my answer is 23 degrees. On B, I have an equilateral triangle, and a couple ways to think about it. If this was equilateral, then that means that this is 60, this is 60. Up here would be 60, which means that this is a 30 and a 30. So I actually have a 30, 60, 90 triangle. And what I know is that the one across from the 30, which is 2x plus 5, if I double that, I get my hypotenuse, which is 6x minus 4. Another way to think about it is just thinking about it as an equilateral, that this whole distance is going to be the same as this. And if that first half is 2x plus 5, then this is a 2x plus 5. So I actually have 2x plus 5 twice. So I am going to solve this, and I get 4x plus 10 is equal to 6x minus 4. I get 2x is equal to 14. So I get x is equal to 7. Okay, 7 degrees. On letter C, again, I have parallel lines. And what I know, there's a couple of different ways I can think about this. I do know that if this is 63 here, that this is also going to be 63 here, because parallel lines mean that corresponding angles are congruent. Now I have a situation, and I can think of it one of two ways. I can either put this as an 80 because 180 have to make a straight angle. And then I know that x plus 80 plus 63 has to equal 180 and solve. Or I can think of it this way. And if I'm looking at this triangle here, I have this exterior angle, okay, of 100. That's going to equal the sum of the two remote interior angles. So let me write that here in green. That would be x plus 63 equals 100. In both cases, when I work it out, I am going to get 37 as my answer. You can think of it either way. Okay, so here, again, we want to show work. This is 53 degrees. From my 53 degrees, this is going to be opposite. This is going to be adjacent. So if I think of SOHCAHTOA, I have opposite and adjacent. So I'm going to use tangent. Tangent of 53 degrees is equal to opposite, which is 13, over adjacent, which is x. I am going to multiply this side by x, multiply this side by x. When I do that, these x's here are going to cancel out. And I am going to end up with x times tangent of 53 degrees is equal to 13. I then am going to divide by tangent of 53 degrees and put that into my calculator, making sure my calculator is in degrees. So 13 divided by tangent of 53. My calculator up. So 13 divided by tangent of 53. I end up getting 9.796. So let's say 9.80 as my answer. On letter B, in this situation, from my 46, this is going to be opposite. This is going to be hypotenuse. So then again, if I'm thinking of SOHCAHTOA, I have opposite and the hypotenuse, which is going to be sine. So I'm going to do sine of 46 degrees is equal to opposite, which is y, over hypotenuse, which is 9. I am going to multiply both sides by 9. And that's going to make those cancel out. And so I'm going to have 9 sine of 46 degrees equals y. I'm going to put it into my calculator. Let this focus a little more. So 9 sine of 46 degrees. And I end up with 6.47 as my answer. On letter C, just move this. From here, this is going to be adjacent. This is going to be hypotenuse. So again, if I'm thinking of SOHCAHTOA, I have adjacent to hypotenuse, which means I have cosine. So I'm going to do cosine of 61 degrees is equal to adjacent, which is 7, over hypotenuse, which is x. I am going to multiply both sides by x. And when I do that, those are going to cancel out. And I'm going to have x cosine of 61 degrees is equal to 7. I am going to divide both sides by cosine of 61 degrees. And so when I take 7 divided by cosine of 61 degrees, I end up with a 14.44 as my answer. So on the next one, we want to decide which of these can be lengths for a triangle. So what I'm going to do is I am going to see about getting each of these. Let's just say I take the ones at the end. Doesn't matter. Choose one of them. So if I'm trying to see if 8 works with a 3 and a 5, what I'm going to do, and here, let me circle them in different colors so you can see the different ones I did. Okay, so in green, I am going to be doing the 3, 5, and 8. So basically, if I take my 3 and 5 and add them and subtract them, always do big minus small. I get an 8 and I get a 2. So what has to be true is this 8 right here has to be in between these two. So basically 2 less than 8 less than 8. That is not true because 8 cannot be less than 8. So 1 is not going to be an option. Okay. So let me try the next one, 5, 8, and 12. So I'm going to add 5 and 8. I'm going to subtract 5 and 8. I get a 13. I get a 3. Is 12 in between those? Yes, 12 is in between 3 and 13. So this is a yes. Okay. Now let me try the last one, 7, 8, and 2. So I'm going to add 7 and 8, and I'm going to subtract 7 and 8. So I get a 15 and a 1. And we want to see, is 2 in between those? And yes, it is. So 2 and 3. So that's going to be letter E. On 11, because she daydreams while grading, Miss Rhea is known for making errors when correcting her students' papers. On any given problem, she has a 30% chance of grading the problem correctly. That is marking a correct solution as correct and a wrong solution as incorrect. Maria is pretty good at math, but on any given problem, she has a 70% chance of getting the answer correct. Maria took a 1-question quiz in Miss Rhea's class. What is the probability she'll get 100%? What is the probability that she does the problem correctly but is marked as wrong? So I am going to get a area model here, okay? And for this area model, I'm going to split it into a 2 by 2, basically. One side is going to be Miss Rhea, okay? And the other side is going to be Maria. So this side's going to be Miss Rhea. And we are going to say here that she has a 30% chance of grading it correctly. So 0.3 chance of grading correctly. Let me just zoom in here, write this a little smaller. Grade properly. I'm going to say properly. And that means that she has a 0.7 chance of grading improperly. Then we have Maria, and Maria has a 0.7 chance of answering it correctly. So this is going to be Maria. And she has a 0.7 chance of answering correctly, which means she has a 0.3 chance of answering wrong. Okay. Answer correct. Answer wrong. And then I'm going to work these out. So when I work these out, this is going to be 0.21. This is going to be 0.49. This is going to be 0.09. And this is going to be 0.21. Now, understand what each of these boxes means. So if I am here in this box, Ms. Rhea properly graded it. So since Maria answered it correctly, and Ms. Rhea graded it correctly, she got this one marked right. Okay, she got that marked right by Ms. Rhea. Now here in this spot, Ms. Rhea graded it properly, Maria answered it wrong. So this one, Miss Ree marked as wrong. Over here, this column, this is where Miss Ree was daydreaming and marked things not properly. So in this situation, when she was grading it wrong, but Maria had the right answer. So since Maria had the right answer, but Miss Ree marked every answer not properly, this means that she actually got it wrong from Miss Ree. This one here, Miss Ree again graded it improperly and Maria answered it wrong. So when Miss Ree graded it improperly, she actually marked it as right. So the situations where she would have gotten 100% would be here and here. So that is going to be 0.42 probability of getting 100%. Okay, what is the probability that she does the problem correctly but is marked wrong? Okay, so that she does the problem correctly, let's take a look at that. She does it correctly, but is marked wrong. So let me just get a different highlight. Okay, so this is where she did it correctly, okay? So she did it correctly, but is marked wrong, okay? So in this case, so again, if we're looking at this, just get rid of all of these so we can focus, okay? So that she does it correctly and is marked wrong is 0.49 chance, okay? So you got to be careful with the wording and understand that if Miss Rhea is grading it properly, then anything that Maria did correct was marked correct, and anything that she did wrong was marked wrong. But if she's not grading it properly, then what's going to happen is anything that Maria did correct, she's going to mark wrong. And anything that Maria did wrong, she's going to mark correct. So you just got to really think about it when you answer that question. Okay, over here. So we have the spinner. We know that this is 60 degrees. So this is going to be 60 out of 360 or 1/6 if we want to reduce it. This is going to be 120 out of 360, or if we reduce it, that is going to be 12 over 36, or see 12 over 36, which is going to be 1/3, or 2/6 if you want to think of it in 6. My D, this is going to be 90 out of 360, or 1/4. B and E are vertical angles. So this is also going to be a 1/6 or a 60 out of 360. Let me leave it like that for right now. And so if I have 60 and 90 together, that makes, so 60 and 90, that makes 150. So that leaves us as 30 out of 360, or 1/12. Okay. So when we're looking at this and we're trying to figure out these probabilities, for A, it is going to be, again, 120 out of 360, or 1/3. For B, it is going to be 60 out of 360, or 1/6. B or C would be these two together, which is actually going to be 1/4, okay, or 90 out of 360, or 1/4. 1/4. Probability of not getting A. So A is 1/3. So basically it is going to be 3/3 minus 1/3, which is 2/3. That's how I would think about it. Or 360 3/60ths minus 120 3/60ths, which is 240 3/60ths, which reduces to 2/3. On 13, here we have a situation where these are vertical angles. These angles are the same. They also are giving us that this line here, that this, oops, sorry, I have it in highlight, wrong highlight, that this side here and this side here are parallel. Okay, so if I cut it by this transversal, for example, then this angle here and this angle here would be the same. And so right now I do have angle, angle. So let me just kind of color code things real quick. Okay. So I have this side here, which is the one I want, X, is going to match with this one. And I have this side here, which is an 8, that is between, that's across from the orange angle. So that's going to correspond with this side here with the 10. Okay. So I'm not going to be using the 6 at all. So when I set up a proportion, I am going to do X over 9 equals 8 over 10, for example. And I'm going to cross multiply and solve. So when I cross multiply, I get 10x is equal to 72. So x is equal to 7.2. And that's my answer. And that's the end of this video.